Aarti, can you hear me? NP, Srikanth, Zafar, Venkat. If you guys can hear me, please type in yes in the chat window. Well, yesterday we discussed about what are the different tools we have in SAP BOBI 4.0, 4.1, XI 3.1. Okay, and what are the tools that are obsolete in BA 4.0 when comparing with XI 3.1? How the nomenclature of the tools has been changed when comparing with XI 3.1 to BA 4.0. A overview of all SAP BOBI platform. Now this is the main diagram. Before start report development using web intelligence, when the client required ad hoc reporting, dashboard design, when the client required dashboard reports, highly formatted reports, or they want to use business object explorer, business objects analysis. Based on the source system, first we need the semantic layer to be designed, the universe to be designed. Once the universe is designed, we can use this universe in various reporting tools like in web intelligence, in crystal reports, in dashboard design for developing the reports. So today's our class agenda is semantic layer. First we'll start learning data manager tool. What are the data manager tools? The tools which we'll use to design the universe. Data manager tools. So once we learn how to design the universe, then using this universe we can start learning different types of reporting tools in BA 4.0 as well as in BA 4. Environment. Semantic layer or the universe. What is a semantic layer? Okay. What is the advantage of this semantic layer? What exactly this semantic layer? What is this universe? The semantic layer is a business representation of corporate data that helps end users and the report developers to access the data autonomously using common business terms. Developed and patented by business object, it maps complex data into familiar business terms such as product, customer, or revenue to offer a unified consolidated view of data across the organization. By using common business terms rather than data language to access, manipulate, and organizing the information, it simplifies the complexity of the business data. These business terms are stored as objects in the universe, accessed through the queries and reports. The semantic layer insulates business users from underlying data complexities while ensuring that business is accessing the correct data sources and using consistent terminology. Benefits include improved end-user productivity and greater business autonomy from IT accessing the data. Okay. Now this is a source system. The source can be a database. The source can be a MOLAP application like BW, Hyper base. The source can be a file, anything. Based on the source, we require a report using various reporting tools. We know what are the main reporting tools. Sorry, folks. Oh, so okay. I will make. So yeah, Srikanth is now organizer. Okay. Okay. This is a reporting tool. And the source can be anything. It can be a database, it can be a data warehousing application, it can be a transactional system. Using this reporting tool, when a business user or a report developer connecting to the source directly for the reporting, then the report developer or the business user needs to have the complete understanding of the source system. For example, we discussed about SAP HANA. Now, if a business user is directly connecting to the SAP HANA using a reporting tool, then the business user or the report developer is supposed to have the good knowledge of HANA tables, HANA views, everything, right? But we cannot expect that much of technical expertise from the business users or from report developers. Suppose as a report developer or as a business user, if I'm connecting to a database for the report generation, what I'm supposed to know? What is a table in the database? How to join the tables in order to retrieve the data in a meaningful format? And there are other concepts as well. Technically, they have to be strong. Otherwise, they cannot directly generate the report from the source system. But we cannot expect that much of technical expertise from the business users, from the report developers. So what we will do is, in order to make the report developer jobs easier, in order to make the business user jobs easier, or in other words, let me put it this way. In order to isolate all the technical complexities of the source system from the business users, from the report developers, what we will do is, based on this source system, first we will create a semantic layer. What is a semantic layer? A layer between your source and reporting tool. Now the question is, does it contain the data physically? No. It does not contain the data physically, only a layer. Basically the universe is a file, a metadata layer, a file which consists of some metadata. We'll see what type of metadata it will consist of. Now in our team, in business objects BOBI team, we have a designers. Who are the designers? The designers are the BO consultants who are expert in designing the universes based on different source systems, because they have the complete understanding, knowledge, technical expertise of the source system, how the different source systems will work. They know all these things. Okay, how a database will work, what are the objects in the database. Okay, so the team member who are experts in designing the universes, they will design the universe. Not everyone else in the team supposed to have a good understanding of the source systems, including the business users. Only the universe designer is supposed to know the technical complexities or the technical, other structure of the source system, not everyone else in the team. Once the universe is designed by universe designer, they are going to deal with all the complexity of the source system, how to design the universe based on the reporting requirements and all. Once the universe is designed, once the universe is in place, then the business users and the report developers will use this universe to generate the reports, for ad hoc reporting for the business users and to design the reports. In this way, we can completely isolate the technical complexity of the source system from business users and the report developers. Only the person who is responsible for designing the universe, they're supposed to know the technical complexities of the source system and the structure of the source system, not everyone else in the team. So the main purpose of business objects universe is, there are so many advantages, we'll see all those. First one is, the semantic layer insulates business users and the report developers from underlying data complexities, while ensuring the business is accessing the correct data and using consistent business terminology. What is a universe? Universe is nothing but a semantic layer. The business object universe is a semantic layer that isolates the business users from the technical complexities of the databases where the corporate information is stored. For the ease of the end user, universes are made up of objects and classes that map to the data in the database, using everyday terms that describe their business environment. This means that by using a universe to create a query, users can retrieve exactly the data that interests them using their own business terminology. Now we'll see what exactly a universe consists of. Okay. There is a company. The company name is eFashion Stores. eFashion, INC. They have retail stores in different states. In 8-10 states. And they require the reports. They are using a database to store all their data. Based on this database, we require the reports. First, from this source, whatever the tables that are required, based on our reporting requirements, the universe designer. See, the universe designer created this universe by including the table structures, by joining. There are so many challenges here. By resolving the loops, by resolving the traps, by testing thoroughly before deploying in the production CMS. Then by creation of the classes and objects. See, all the technical complexities are taken care by designers. Once this universe is created, for example, once this universe is created, I am a report developer or I am a business user. I need a small ad hoc reporting using web intelligence. So using a reporting tool, I'm not directly connecting to the source. If I'm directly connecting to a source, I have to deal with all the complexities of the source system. Now I'm not directly connecting to a source. A semantic layer, a universe is designed based on the source system. A universe internally connects to the source system. Now I'm selecting the universe. See, I'm selecting the universe. See here. See how easy interface to create. I'm not directly connecting the source system. Already the universe designer included the table structures based on the table fields, whatever the reporting requirements we required, created. The designer created the objects like dimensional object, detail objects, measure objects. Only these objects will be visible for the report developers, for the end users. Even I don't have any idea from which table this object is coming, from which table, which field this object is mapping. That is none of my business. So I will select the universe, I will design the report. That's it, I will design the query. Just imagine using this tool if I'm directly connecting to a database, okay, these tables, these fields, okay, resides in which database tables, how to join these two tables, how to retrieve the data in a meaningful way. I have to deal with all these complexities. Here someone else already did all these things. Just we are selecting the objects in the reporting tool and we are designing the query as per our reporting requirement. So which one is simple? Directly connecting the source system or designing the universe, okay, and almost say 70 to 80% of the business requirements we can achieve here itself while creating the objects. Then in remaining in the reporting tool we can create the calculated measures or any other extra objects in order to achieve our reporting needs. So definitely it makes sense by creating the universe, then designing the reports based on this universe. Now what exactly this universe consists of? See, the universe is maps to the business data where the corporate data is stored. A business object universe is a file. As I said, the business object, the universe is not a physical container of the data. It's not like a database table where we'll store the data physically. No. It's not like a cube where we'll store the data physically in OLAP applications. No. It's only a layer. It's only a metadata layer. So once you create the universe, once you save the universe, the system will generate a file. Now if you are creating the universe, we have two main tools. As I said, universe designer tool, information design tool to design the universe. Again, among these two tools, the main one is information design tool, IDT. Still, UDT also supported from BA 4.2 onwards. If you save this universe, if you are creating the universe in UDT, Universe Designer tool, see the file extension is UNV. Because the universe is a file. If you are creating the universe in information design tool, the new tool given by SAP from BA 4.2 onwards, we'll use this tool only to create the universes. See, the extension of the file is UNX. Universe is a file, there is no doubt. But the file extension if we are creating the universe in UDT is UNV, and the file extension if you are creating in IDT is UNX. So if you are creating this universe in UDT, UDT is a short form of Universe Designer tool, the system will create a file with extension .unv. So the conclusion is all UNV universes are created in UDT. If you are creating the universe in IDT, it's also a file. IDT is a short form of Information Design tool. The extension of the file is UNX. So UNV universes, UNX universes. So what are the UNV universes? The universes which are designed in Universe Designer tool. What are the UNX universes? Which are designed in Information Design tools. Now, universe is a file. It's not a physical storage of the data like database, table, or queue. Understandable. Now, second one is, now my interest is what exactly this universe consists of. It's a file. Okay, what type of metadata it consists of? First one, connection parameters to the source. Because whenever I'm selecting this universe in a reporting tool, once I execute the query, in runtime, the tool will generate the SQL based on the query. It will pass on to the semantic layer. Semantic layer has to connect to the source system in order to execute that query in the source. Because semantic layer is not a database. It cannot execute the query. In database only we can execute the query. Database only we have the SQL parser, it can understand the SQL. So always semantic layer will have a connection to the source. First, it's a file. What exactly this file consists of? First one is connection to the source. Connection parameters. We'll talk about connection, what is secure, unsecured, and all. See, connection. This can be ODBC connection or JDBC connection. Connection. Second, schema. We'll call it as schema in UDT. Data foundation in IDT. The terminology is different in IDT, but the concept is same. Schema in UDT, data foundation in IDT. What is the schema? Why we require the schema? Now, we are designing a universe for sales reports. The business required reports for sales reports. Sales universe. But sales data resides in different tables. For example, sales order header table, in a database. These are the sale order tables. Sale order header table, item table, schedule line tables, okay. Based on these table fields, we require the report. Sales reports. This is a sample report. In this report, year, quarter, these are the fields in a database table. Maybe a time, okay, some table. City, state, shop name, these are the fields in maybe in another database table. Okay, margin, amount sold, quantity sold, maybe these are the fields in another database table, right? In the same way, in the sales reports, we need the fields from different database tables. Sold to party, shipped to party, okay, and other sale order header details from sale order header table, item level details from item level table, schedule line level details from schedule line table. In that case, as per our reporting requirements, once the connection is successfully established, second one is we'll import these table structures. Because in order to generate the reports, okay, in order to, what are the reports we require on top of this universe? Let's say I need 10 reports on top of this universe. In each and every report, what are the fields we require? And those fields are spread across how many tables in the database? We'll insert all these table structures and we'll join these tables. Basically, we'll create a schema. Because if you don't have a join between the tables, the data will be retrieved using Cartesian product. In order to retrieve the data in a sensible format, we need to have a join. So second is, the universe consists of first connection to the source. Second, this is called universe schema. What is a universe schema consists of? A set of database tables, the structures only. These are the structures of the database tables along with the joins. So how many tables we required? We have to, how many table structures we have to insert from the database table? It depends upon our reporting requirements. This is called schema in UDT and data foundation in IDT. See, we inserted only one table here, but we can insert more than one table also. It depends upon our business needs. See, data foundation. So the second is schema in UDT. Connection is same. In IDT and UDT will refer as a connection only. See, connection. All these are the connections. Third one is objects. Now once we included the tables and we created the schema, then finally we have to create the objects. In a report, what are the objects we require? As I explained in HANA modeling, if you consider any report, in a report we require dimensional objects. See, if this is a report, in this report year is a dimensional object, quarter is a dimensional object, city is a dimensional object, state is a dimensional object, shop name is a dimensional object, margin is a measure object, amount sold is a measure object, quantity sold is a measure object. Based on our reporting requirements, see, we'll create dimensional object. What is this dimensional object? A field in a database table. See here. But while creating these objects, we'll follow proper naming conventions so that the terminology can be used by different business users across the industry. Consistent business terminology. If you look at this example, here the field name is YR, but YR doesn't make any sense in the report. We need to have a proper naming convention. See, year. So what is year? Year is mapping to year field, YR field in the table, in a database table. The database table we already include the table structure of the table we already included here. See? The orange ones are measure objects. What is a measure object? It's also a field in a database table. So if you look at the shop facts table, see margin, amount sold, or quantity sold, quantity sold, amount. See, all the sales revenue means amount sold. Change the naming convention. But what exactly this field? This field is maps to a database table. Field in a database table. So we'll create the objects. Here we have three types of objects: dimensional object, measure object, detail object. Detail object means, suppose there is a store name. For store name, zip code and address, I can create these two as a detail object. These objects are grouped in classes. See, this is a class. All related objects will be grouped in one class. The folders are here, nothing but classes. Time period is a class. Store is a class. Product is a class. Promotion is a class. Measure is a class. But in IDT, we'll call it as a business layer. See, if you look at the business layer, what exactly the business layer consists of? Here we'll call it as the folders, not classes, folders. Again, under folders we have dimensional object. We can have attributes as well as measure objects here. So once you save this universe with connection parameters, that can be a JDBC or ODBC connection, with this schema and with this classes and object, the system will generate one file. Connection, schema, classes and objects, the system will generate one file. If you are creating this universe in UDT, the system will generate UNV file. If you are creating this universe in IDT, using connection, data foundation and business layer, it will generate one file, that is UNX. Now here the interesting thing is, whenever the business user is selecting this universe in a reporting tool, which part of the universe is visible to the business user? Which part of the universe is visible for the report developer? As a report developer, as a business user, I have nothing to do with this schema. I cannot understand that schema, how the tables are linked, okay, how the loops are resolved, because I am not a technical person. I don't know how the connection is established. Only the thing I required is objects for the reporting. This part I need for the reporting in my reporting tool. So whenever as a report developer, whenever as a business user, if I am selecting a universe in a reporting tool, it lists only the objects and classes from the universe. It lists only the business layer from the universe, not schema or not data foundation, not the connection. This is a universe. That can be UNV or UNX. First I will select the UNX universe. See which part is visible as a report developer? Only business layer. See, in the business layer, here in this universe, in interaction universe, I have, okay, whatever that one. Because only these objects are required for the report to design the query, not okay, all other. So once I designed the query, this reporting tool generates corresponding SQL here. See here. So this SQL reporting tool will generate a SQL. The reporting tool will pass this SQL to a semantic layer. Does semantic layer contain the data physically? No. Now the semantic at runtime, the semantic layer has a connection to the source. See, connection to the source. This query will be passed on to the source. The query will be executed here, database, and the result will be displayed all the way from source to reporting tool. So at any point of time, see here, it's not storing the data. It's only this layer is helping to avoid the business complexities, source system complexities from the end user and business user, and to provide the security and data. And there are so many other users. I will list those users. At any point of time, it doesn't contain the data physically. So now if I execute this one, if I execute this query, the data is coming from source, not from, I have some connection problem, I was showing that one. So the data is coming from the source, not from the business, semantic layer, not from the universe. So what exactly business user consists of? A semantic layer consists of. A business object universe is a file that contains the connection parameters to the source, a schema of the table joined, okay, and the objects. So basically, you are not storing any data in the semantic layer. It doesn't contain the data. Basically, the semantic layer, the universe is a file. It is a UNV. The extension of the file is a UNV. If the universe is designed in UTT, and the extension of the file is UNX if the universe is designed in ITT. Yeah, any questions, folks? Yes, I will explain very clearly, Venkat, what is a detail object when we are going to start the classes of, okay, objects. Whenever I am creating the objects, so I will explain very clearly what are the dimensional objects, detail objects, okay, and the measure objects, how the concept is enhanced in ITT also. This is only what is semantic layer. After completion of the overview of semantic layer, first we'll start with the connections. Then we'll start with the, okay, joins, different types of joins. What are the different types of joins supported? Then we'll go to the classes and objects. Then we'll start loops. Then we'll start the SQL types. And now to answer your question, what is detail object is, just to give an information, a brief overview. A detail object always associates with a dimensional object, the main object. Suppose I have the main object is a state. Or if you look at this example, the main object is, main dimensional object is store name. But what are the detail object associated, what are the detail object associated with this? Address of the store, zip code of the store. What is detail object? Detail object always associated with a dimensional object, which gives the more information about the dimensional object, which describes the dimensional object in a greater detail. So in the report, along with shop name, I need shop zip code as well as and shop address. So these two cannot exist independently. See, plus mark. Always the detail objects or attributes associated with the main dimensional object. That is a brief detail object concept. Okay, we'll see in detail in our classes and objects class. Yes, NP, what is your question? Yes? Yeah, can you please go ahead with your question? I have to continue the session.
Yeah, did you unmute? Can you hear me?
Yeah, I can hear you.
Okay, can we do the field level or object level security in IDT so users can only see the fields that I allow them to see through
Yes.
Webby?
Yeah, we have the security concept in the universe. So we have, okay, row level security. There are different in security option also. There are so many enhancements in IDT. So we'll cover the security option also. This is a two way to talk about the security, but we'll cover in depth of universe security.
Okay, okay, thanks.
Yeah, always muted means because if you unmute, it's echoing and it's going to affect the recording. That is the reason why unmute. So if you have any question, just raise your hand. Just how the NP raised a hand, then I can unmute you in order to answer, ask your question. So I cannot unmute everyone. The reason why I'm not unmuting everyone is if I unmute anyone, the echo noise will come and it will impact the recording. So you cannot get very good quality of the recording. Okay. So whenever you guys have the questions, please raise your hand so that I will unmute you. Whenever you raise hand, right away I will get a notification here. Someone raised your hand. Okay. The role of the universe. The role of the universe is to present a business-focused front-end to the SQL structure in the database. The data used in the universe schema depends greatly on the end-user requirements. Means what are the tables we have to insert to create the schema, to create the data foundation. It depends upon our reporting requirements. Once we have the universe ready, then we can run the queries against, okay, we can create the reports, perform the data analysis. The main advantages of the universe. One of first main advantage is only the universe designer needs to know how to write the SQL, understand of the source system, the complexities of the source system, or the complexities of the target database, not everyone else in the team. That is the first one. Second, the interface allows you to create a universe in a easy to use graphical environment. So whenever we are creating the universe here in UDT or IDT, it's very GUI based, easy to use interface. Creating the connections, creating the data foundations. Okay, for everything we have GUI based environment. So really you don't have to work hard to create the universe. Only the thing is you require the complete knowledge of the source system. Data is secure because once we created the universe, on universe we can impose the different types of securities. We'll talk about the security. We have row level of security. There are different security options given by SAP at universe level. So by imposing all those security on universe level, the data is highly secure. User can see only the data exposed by the universe. User can only read the data. They cannot edit it. The results are reliable and universe is relatively easy to maintain because once we created the universe, at every phase of the universe, we'll test the universe thoroughly to make sure the universe is designed as per our reporting needs. So the data is reliable. The results are reliable. User can use a simple interface to create the reports. See here, whenever I'm selecting a universe in any reporting tool, it's showing me very simple user interface. It's not showing me, okay, hundreds of tables from the source. Okay, I confused which table, which field of the table, which one I have to select for my report. For my query. See how easy interface here. Only it will show your objects. That's it. Not your data foundation, not your schema, nothing else. Very easy user interface to design the queries for the users, for report developers. User can only all users can work with business, consistent business terminology. Maybe the year is the field name is YR, but we don't need that naming conventions. We need in a report the nomenclature which is understandable by all the business users, okay, with consistent business terminology across the enterprise. See here how when the business universe designer is creating the objects, using very meaningful naming conventions, we are creating these objects so that everyone can understand the nomenclature of these objects in the reports, not the direct field names. So users can analyze the data locally. So these many advantages we have the universe. Well, there are on another side, there are some source systems. If you create the universe on top of the source system, maybe it reduces the performance. Like on top of BW, whenever we are creating the universe up to XI 3.1, we require the universe. So there are so many issues. That is the reason SAP eliminated the universe concept on top of BW. That is exception case. We'll talk about that whenever we are dealing with BW as a source. Now the question is, what type of databases we can use? What type of source systems we can use to design the universe? Before developing a universe, you must familiarize yourself with the underlying data. Which type of database schema is going to be used for the universe? Will this be a data warehousing model or OLTP model? Any of these models can be used. It's normalized model, okay, aggregate tables, star schema, snowflake schema, multiple star schema. These scenarios also I will show you. There are no restrictions. Now, a client is implementing SAP BOBI project. They require some Webby reports, dashboard reports, crystal reports, and they need the universe to be designed. So what is the universe development lifecycle? What is typical universe development lifecycle? What are the different phases in a universe development? First one is planning, analysis, design, implementation. Distribution means granting the access to the different business users and report developers who require the universe, then maintenance of the universe. So these are the different phases in a typical universe development lifecycle. First, preparation. Now the client required some sales reports, inventory reports, some FI reports. The source is Oracle database. The source is SAP HANA database. Preparation. Identify the universe scope. Build a project team. Adapt the standards. Conduct the meetings. Analysis. Identify the candidate objects. What are the candidate objects? In how many reports we required on top of this universe? In each and every report, what are the dimensional objects? What are the detail objects? What are the measure objects we require? Give me 1 second, folks. Just I'm trying to explain what is candidate objects. Okay, a utility client, they are implementing SAP BOBI project. They required asset work reports, asset portfolio reports, inquiry and complaint reports, finance reports. In asset work reports, they need service level performance report, performance work completion summary, these are the reports they required. Now, once we have what are the reports we required, see, we have to identify the candidate objects. In asset portfolio reports, what are the dimensional objects we required? What are the measure objects we required? See here. This is nothing but identifying your objects, what we required in the report. That can be a dimensional object, detail object, or measure object. Yes, NP? You raised your hand?
No.
Okay. See, in the analysis, once we prepared, once we have the team and everything, in the analysis, okay, in each area, what are the reports we require? Again, in each report, what are the candidate objects we require? Then, what is our source? Okay, relational modeling versus multidimensional modeling. Then planning. Create a project plan. Plan the business objects architecture. We need development, testing, production environments, CMS. We'll talk about what is CMS. Implementation. In the implementation, our universe designers will connect to the source. They will design the universe. Okay. Again, in the universe designing, we have different phases. I will explain. Okay, we are going to learn each and every phase from tomorrow onwards. So, object qualification, table diagram, see all this. Review join strategies, joins, okay, resolving the loops, traps. There are so many concepts. And testing is very big phase. Even if you join two tables, like what are the join you are using? It can be inner join, left outer join, right outer join, theta join, full outer join. You have to test it that join is working properly. So if you create any object, it has to be tested thoroughly in the universe. Then deployment. Once we are done with thorough testing, then we will deploy the universe in a production environment. So architecture, production environment, granting, once the universe has been deployed in the production environment, then we will grant access to the universe. We already impose the security on the universe for which business user, okay, what type of security they required, what type of they required, what type of data they required. According to all our security restrictions, we already created. Conduct the training, how to use the universe, especially for the business users, okay, to design the reports in Bobi, okay. Then universe maintenance. As per our requirement changes, adding some new fields to new objects to the tables, corresponding tables in a schema, all these are ongoing maintenance activities. This is the first phase, universe development process. Prepare. What are the reports we required? What are our source systems? Then identify the candidate objects. What are the objects the business users required? What are the dimensional objects? What are the detail objects we required? Then prepare the business blueprint. Plan. Then create in the system, in the development environment. Test thoroughly in a testing environment. Deploy in the production environment. Grant access to the business users who require access to this universe. Not only business users, report developers as well. So first we'll start learning the universe with SAP HANA as a data source. Because we learn SAP HANA, the concept is same. If you are working with Oracle, SQL Server, I will show with other databases also like SQL Server, MS Access database. But first we'll start with SAP HANA. So we'll cover SQL Server also. So whenever we have to design the universe, once our blueprint is ready in development environment, the tools we are going to use, the universe is, we have two tools, UDT and IDT. Universe Designer tool, Information Design tool. See, we have UDT and IDT. Now which one has to use? Why we have to use? Which one is preferable and why? Even if a client is implementing BA 4.2 or BA 4.1, SAP BOBI 4.2 or BA 4.1, IDT is preferable, not UDT. Why? What is the reason behind that? Most of the new BA 4.0 reporting tools, like Crystal Reports for Enterprise. If you want to use the query browser in Dashboard Design 4.4, if you want to create an information space in BO Explorer, based on the universe, most of the new BA 4.0 reporting tools supports only UNX universe. If a client wants to utilize all the new features of the tools, new BA 4.0 tools, most of the new BA 4.0 tools supports UNX universe. Just now we discussed what is UNX and UNV. UNX, the universe we created in Information Design tool. UNV, the universes which we created in Universe Designer tool. So most of the new BA 4.0 reporting tools supports UNX universes. But the WebE is the one, WebE 4.0 supports both the universes. WebE 4.0 supports UNV as well as UNX. But majority of the new BA 4.0 reporting tools supports UNX. That is the reason it's recommended to create the universes in UNX. Well, having some idea about UDT is always good. The reason is, still there are so many clients. There are some clients who are using XI 3.1. Suppose you land up in a project where the client is using XI 3.1, then UDT. Second option, a client is upgrading from XI 3.1, XI 3.0 or XIR2 to SAP BOBI 4.0, 4.1. So if you have the knowledge about UDT in the migration projects also, it's very helpful. And BA 4.0 is new in the market, like in 2011 only it's introduced. So you cannot show more than 3.5 years experience in BA 4.0, maximum 3. So if you want to show rest of the experience, then XI 3.1. In that case, you're supposed to have some idea about UDT. Always having some idea about UDT is well and good to work in upgradation projects, migration projects, okay, and to show some experience in XI 3.1. So in this course, I will give you some introduction to UDT also, okay, brief idea, so that you can understand both the tools in a better way. One concept in UDT, how the same concept is enhanced in IDT, why they are enhanced, what are the advantage of enhancing that option like that. So you have clear understanding of both the tools. But we will use, okay, most of our times we will spend on IDT only. How to launch UDT or IDT? In order to launch UDT and IDT, once you logged into RDP, Remote Desktop Connection, start, all programs, SAP Business Intelligence, SAP Business Objects BI 4. Client Tools, click on Universe Designer tool, click on Information Design tool. Or you can create a shortcut on your desktop also. So whenever you are launching the tool, here we have to provide some information. The system, the username, the password, the authentication. What is this system? The system is nothing but Business Objects Repository. Yesterday I was giving a brief introduction to Business Objects Repository. In every project, so we'll have the main server. The purpose of the server is to store all the objects related to that object. So we'll take the frequently backup of the server. Okay. Here also in business objects also, there is a concept of BO repository. What is repository? Where all the objects will be saved. Or we will call this one as a BOCMS or CMS. CMS stands for Central Management Server. Central Management Server. Once the base BO administrator install this Central Management Server, the Central Management Server will be installed on the database to store all our objects. The purpose of this Central Management Server or BO repository to store our BI content. To store our BI content. This Business Object Central Management Server consists of 3 parts. Means you can say 3 areas. First one is Universe domain. Second one is Document domain. Third one is Security domain. Okay. In a system landscape, we have Dev CMS, QA CMS, Production CMS. Or we can have sandbox also sometime. So now in a universe lifecycle, I was talking about deployment of the universe. Where we are going to deploy the universe? The universe will be deployed in a CMS. Now, I'm designing the universe using UDT or IDT. After designing the universe, the system will generate, once I save the universe, UNX or UNV file. Where I need this file eventually, I need this file in a CMS because it's also one of the BI content. Using the universe will generate the reports. So once you export the universe will be saved in a universe domain. So in order to export the universe to the business objects repository, because after creation of the universe using these tools, I want to export the universe to the universe business object repository or CMS. So by launching this tool, you have to connect to the business object repository. While launching this tool, you have to connect to the business object repository. So that is the reason all the business object tools are referred as client tools, because you have an option of connecting to the business object server while launching that tool. See, business object from client tools. Why these tools are named as client tools? Because whenever you want to launch these tools, using these tools we can connect to the CMS. Okay, I'm launching UDT or IDT. I can connect to the CMS because once I design the universe, I can export the universe to universe domain. Now I'm launching Web Intelligence. while launching Web Intelligence also, I can connect to my server. This is a client, this is a server. Because once I designed my Webby document, I want to export to CMS. Whenever you are developing any reports, Webby reports, Crystal reports, all the reports will be saved in a document domain. All the universes will be saved in a, whenever you are developing the universes using UNV and UNX, after exporting, those universes will be exported to universe domain. And the security domain consists of the security objects like universe security objects, users, okay, corresponding profiles, all the security objects. So whenever you are launching a tool, don't forget to give your CMS name, your credentials, because once I design the object in that tool, that can be a Webby document, that can be a universe, I need that object to be exported in business objects repository or business object central management server. That is nothing but system. So one time if you give the system access, next time you don't have to give. Automatically it will show you. Our central management server name is BODS41 SP6. BODS41 SP6. The credentials, I'm using administrator, but you will have your own username passwords. And this username exists in my business objects server. Click on OK. Now you launch this tool by connecting to our business object central management server, where you can find that information on the top. See, Universe Designer tool is connected to BODS41 SP6. This is a CMS running on the port 6400 and using what are your credentials? Administrator. So once you design the universe using this tool, because you launched in a connection mode, suppose I designed a universe. I design a universe. Now I have an option of exporting the universe to a CMS. See? Export. Where I'm exporting? To CMS. Again in CMS you can create your folders. Here, this is CMS. Where I'm exporting? To CMS. What is our CMS name? BODS41 SP6. So why I'm able to export this universe after designing the universe to this CMS is because while launching this tool, I connected to this CMS. I launched this tool in a connection mode to the CMS. See, you can export. Same in IDT also. Once I launch this tool, I am connecting to the CMS. Here, see here, BODS41 SP6 using my credentials. So that once I design the universe here, I can export the universe to a CMS. I can publish to the repository or CMS. Why I'm able to publish this to the repository? Because I launched this tool in a connection mode. Not only these tools, most of the tools in SAP BOBI, that can be a reporting tool, universe designer tool, that can be a data manager tool, that can be a administrator tool, that can be a business user tool, that can be a designer tool, provides the option of, while launching the tool, connecting to your CMS. So that is the reason these tools referred as client tools, because while launching these tools, we have an option of connecting to business objects central management server or BO repository. Yeah, any questions, folks? NP, you raised your hand. So tomorrow we have the regular time because I had a demo session. That is the reason I joined lately. Okay, tomorrow we'll start. Okay, we'll take one database in SAP HANA, one company database, small company database, that is Motors database, and we'll start what type of reports they require. Then we'll start learning with the basics with a small database. Then we'll move on to big tables like SAP ECC tables. We'll import the tables to SAP HANA. Then we'll deal with big tables also. Tomorrow's our class agenda is creating the universe structure, in IDT, connection, data foundation, and business layer in comparison with UDT. So first we'll learn with universe parameters. Okay, connection and all other parameters. Once it won't take much time, hardly 1 hour, then we'll move on to joins. Then classes and objects. I will show you the migration projects also, conversion process also, how we can convert a UNV to UNX universe and all. Yeah, I will resolve this problem, Aarti. Just post in the blog, I will resolve the problem. Yeah, that's all for the day, folks. Good night, everyone.